Hi everyone. Our example this time is a little bit more complicated than the previous one. In this example, asking us to find the equivalent capacitance between point A and B for the group of capacitors connected as shown in this figure. As you see, is complicated and they have been connected in series and parallel, and the amount of capacitance for C1 is 5 microfarad, for C2 is 10 microfarad, for C3 is 2 microfarad. Now, if we look in detail to this circuit, C1 and C2, they are in series connection, and C1 and C2 same, they are in a series combination, because there is no any junctions in between and there is no any other devices. So we will apply a formula of series connection. C equivalent is inverse of the 1 over C1 plus 1 over C2. As you see, if you apply this formula, you'll find out the result of this two will be 3.33, and for the other side is the same 3.33, and between them is just 2 microfarad. So the result of these two with this one, with the result of these two, all three will be in a parallel connection. So for parallel connection, we just adding algebraic amount of them, which we have 2 times 3.33 and just 2 microfarad. So we will add all of them together, will be 8.66 for the upper part of the circuit. For the lower part of the circuit, we have this C2, which been connected in parallel with the other one. In parallel, doesn't matter a junction if there is no any other devices, so both of them are being connected together in parallel connection. So in parallel, as you know, we just adding both of them together. 10 plus 10 will be 2 times 10 equal to 20 microfarad, the lower part. For the total circuit, the lower part and the upper part being connected in series. So the formula of series, as we said, series combination, the result will be 6.04 microfarad. This is a equivalent capacitance of the circuit. In the second part of the example, asking us to calculate the charge on each capacitors if the potential difference between A and B 12 volts. For this part, if we look in detail, we found out for upper part 8.66, for lower part 20 microfarad, and this was the equivalent capacitance, potential difference 12 volt. So the total charge in the circuit is 72.5, which means C times delta V, 72.5 microcoulomb. So the lower part and upper part in series, so the charge on this part is equal to the total charge, as you know, in a series combination. And this is a charge on the lower part and the capacitance of the lower part as we calculated. The potential difference will be 3.625 volt. As you know, potential difference is equal to Q divided by C. So we can find out the charge on each of them from the amount of this capacitance and the potential difference. This is a charge on these two capacitors. We can find out this charge as well from the total charge on this part was 72.5, and they are in parallel, and the amount of C2 are equal. This is 10, this is 10 as well, so the charge of them will be half of this amount, which means 36.25. For the upper part, easily you can find out the potential difference from the 12 minus this potential difference. This is a result for potential difference across the upper part. From this potential difference and the amount of C3, we can find out the charge on the this capacitor. As you know, C3 was 2 microfarad. For those sides, the result from C1 and C2, they were in a series combination. Result was 3.33, and charge is each of them from the result capacitance of both of them and potential difference. We can easily find out, multiply these two, find out the charge on each of those capacitors. So for the other side is really the rule will be applied, and the charge on the both capacitor will be 27.89 microcoulomb. This is the result. If you want to check, the total charge on the lower part is this charge plus that charge, they are in parallel, will be 72.5, and the total charge on upper part should be the same as 72.5. As you see, this side will be 27.89 plus 16.75 plus 27.89 will be the same as 72.5. Thank you for your time. Have a good day.